We're first going to apply the conservation of momentum, and we can say that m sub 1 v sub 1 plus m sub 2 v sub 2 is equaling 0. Now, here we know that then v sub 2 is going to be equaling to negative v sub 1 multiplied by m sub 1 divided by m sub 2. And so we know that the surface is frictionless, and so we can apply the conservation of energy, where we can say the kinetic energy sub 1 final plus the kinetic energy sub 2 final plus the potential energy of the spring final is equaling kinetic energy sub 1 initial plus kinetic energy sub 2 initial, and then again plus the potential energy of the spring initial. Now, we know that the kinetic energy sub 1 initial is equaling kinetic energy sub 2 initial and equaling potential energy of the spring final. So these are all 0. And so we can then substitute and say 1/2 m sub 1 v sub 1 squared plus 1/2 m sub 2 v sub 2 squared equaling 1/2 times k, the spring constant, times d squared, d being the compression of the spring. And so we can then cancel out the halves and say that solving, we can say that rather first we're going to factor out m sub 1. So we can say m sub 1 multiplied by 1 plus m sub 1 over m sub 2 multiplied by v sub 1 squared is going to equal kd squared. And so we're going to say that we're going to choose the negative sign because we know that m sub 1 is going to recoil to the left. Or rather, recoil to left for m sub 1. And so we can say that then v sub 1 is going to be equaling negative d, the negative compression, multiplied by the square root of k, the spring constant. This would be divided by m sub 1 multiplied by 1 plus m sub 1 divided by m sub 2. And so we can then say that solving, v sub 1 would be equaling negative 9.8 centimeters, or 9.8 times 10 to the negative second meters. This would be multiplied by the square root of 280 newtons per meter divided by 0.56 kilograms multiplied by 1 plus 0.56 divided by 0.88. And we find that v sub 1 is going to be equaling negative 1.7 meters per second, or 1.7 meters per second to the left. We can highlight this, and so then plugging this into v sub 2 for the equation for v sub 2 here, we can get that v sub 2 is going to be equaling negative 1.7 meters per second multiplied by 0.56 kilograms divided by 0.88 kilograms, and this is going to be equaling to positive 1.1 meters per second. Of course, 1.1 meters per second to the right. This would give us v sub 2. So this would be our final answer, our second final answer. That is the end of the solution. Thank you for watching.